Now you've come to the lecture about slack space. What's important about slack space is that a lot of large cases were made off the evidence obtained from slack space. For as one portion of a drive or of an operating system where the data is stored that only the operating system has control of, and that the end user really doesn't have control about what goes in slack space. What's nice about that is that most people forget about that, especially hackers. And there are many times in which slack space can give us not the complete evidence, but a lot of small portions of that evidence. Slack space. Slack space is considered allocated space. It's a part of an allocated file or partition and normally cannot be used. Think of it like the refrigerator down here on the right-hand side in this slide. The bottom 4 shelves of that refrigerator are being used, but the top 2 are empty. However, the entire refrigerator is allocated as a refrigerator and space. So technically, the slack space would be those 2 unallocated cabinets at the top. Before we get more in depth in slack space, you should know there are 3 types of slack space. There's memory slack, which refers to RAM memory. There's file slack, which would be slack that is in the allocated side of the files. And there's partition slack. And like the name says, it's slack space within a partition. For the sake of this class, we're going to be talking about slack space that's contained within the Windows operating system environment. So let's first talk about memory slack. Memory slack is created when a file buffer is opened in RAM memory for disk file access. Memory slack basically is the data from the end of the file data to the end of the file buffer. The data in the slack area was the residue in the RAM. Windows, however, will fill this with zeros, but not always. So as you look at the graphic down below, you have a file buffer, let's say, of 200 characters long, or in this case, about 36 characters long. As we write the alphabet out to the file buffer to eventually get to the hard drive, it fills in all the letters, and then at the end of the data, there will be an end of file marker. Everything after that end of file marker to the end of the buffer itself would be memory slack. File slack is the data that resides from the end of the file to the end of a cluster. File slacks can be from 1 byte to the entire size of the cluster minus 1. You have to remember that file slack is a combination of memory slack and remnants from a file that was previously occupied in that same cluster. You will not find the complete files in the file slack, but only part of the files. So as you look at this graphic below, because we're allocating 6 clusters, I write some file data to the cluster. It only takes up 1 sector. I write the end of the file marker. So the file slack would be everything from that file marker to the other 5 clusters until the end, or the end of the cluster. So here's an example of file slack in a FAT as it resides in allocated space. You notice the file data in the cluster that was allocated, let's call it the active file, only takes up so much room. Then we have an end of file marker. Then we have memory slack, because remember, memory is written a sector at a time. After that, because it still has the other 5 clusters that were allocated, there was data found in there. So that data must be from a previously deleted file. If you remember, when we delete files, we actually do not go out and delete the space or zero out the space normally. We just allocate it to be used again for another file. So here's an example, like I said, of a file that could have been originally 1 cluster in length, but then it was deleted, and then a new file was written that was less than a cluster in length. Thusly, we end up getting the file slack. So now here comes the technical part. File slack will follow the file when it is moved in a partition. File slack will change when you copy a file or move a file to a new partition or new media. That's because you're actually only moving the file itself, the actual amount of characters. Like in our previous example, instead of moving 6 sectors to a new partition, it actually only moves the 1 sector in length file and nothing more. The memory slack, the zeros, however, will stay with the file because it's within that sector. When moved to a CD-ROM, the slack becomes all zeros because it is written out as individual characters. So let's take a look at some examples of where if slack moves or doesn't move. When we first create a file, we have file data, we have it in the file marker, we have zeros that complete up the first sector, and then we have sectors 2 and 3 of a 3-sector cluster that may have remnants from a previously deleted file on that partition. But let's say we copy it to like new media or to a new partition. Well, the beginning would stay the same. We have the file data in the file marker and the memory slack. But any data in sectors 2 and 3 would be from remnants of a previously deleted file at that new partition or that new media. If we move the data within a partition, nothing changes. Mainly because the file, all we were doing when we move it within a partition is changing its position in a directory structure and not actually moving the data itself. If we file copy or move to a new partition with smaller clusters, let's say a 2-sector cluster, then the first sector would still be the same. We'd have the file data in the file marker and the memory slack, and we'd have the remnants from a previous file at that new location, just like we would if it was 3 sectors allocated. Let's say we file copy or move to a floppy drive or a thumb drive, where it is allocating space a sector at a time, or the clusters are only 1 sector. Then all we would really have would be file data, the in the file marker, and the memory slack. Nothing else because we're only allocating a sector at a time. The last type of slack that you encounter is partition slack, and basically that is the space between the last cluster of a partition and the end of the partition itself. Partition slack can be from 1 sector to the cluster size minus 1 sector. So if the cluster size is 8 sectors per cluster, then partition slack could be up to 7 sectors in length. That completes our lesson on slack space. Once again, I want to reiterate that slack space is important. It's the one area in which most users have no control about what data goes in, let alone knowing what data is there. Now, it may only be a portion of the evidence you need. It may not be a complete record, although it may be enough to make a case. Let's go on to our next lecture.